An electron with an initial speed of 21.5 times 10 to the 6 meters per second is traveling parallel to an electric field of magnitude 11.4 times 10 to the third newtons per coulomb. In this video, we will find how far will it travel before it stops and how much time will elapse before it returns to its starting point. Now over here, I've written down the known values that have been given to us in the problem, as well as went ahead and looked up the mass of the electron. Now this drawing is representative of what's been described in the problem. These horizontal lines are the direction of the electric field, and this is the particle of interest, the electron. Now the problem states that the electron travels parallel to the electric field, but because the electron has a negative charge, it's going to want to oppose the direction of the electric field, which is why I've drawn the force over in this direction. Now the equations that we're going to use for this problem are F equals charge of the particle times electric field, F equals mass times acceleration, and these two equations of motion. Now, in order to answer the first question, how far will it travel before it stops, we need to figure out the acceleration in order to use the last two equations of motion, because we need to find the distance traveled, but we still have acceleration as an unknown. And so, starting with F equals ma, we can manipulate the equation to get a equals f over m, and then plug in from our list of equations for force and get a equals charge of the particle times magnitude of electric field times, or divided by mass. And from our table of known values, we can plug in those numbers and get 2.00 times 10 to the 15th. Now, as I explained earlier with the diagram, the electron opposes the direction of the electric field. So that means Q would be negative because it's opposing the direction. So the acceleration is actually negative. So now that we have the acceleration, we can plug it into the equation of motion. V final squared equals V initial squared plus 2 times acceleration times distance traveled, and manipulate this to get the distance traveled. S equals V final squared minus V naught squared over 2a. Now, since the question is asking how far it travels before it stops, V final is 0, and if we plug in the rest of the values from our table of known values, we will get S to equal 0.1197 meters, or 11.9 centimeters. And that's the answer to part A. For part B, we need to use a little bit of intuition and think a little bit to find the answer for the time it takes to return to the starting point. Now, the electron will travel just how a ball being thrown up into the air would travel. It will have a starting point, travel up to a maximum height, or in this case the electron will travel up to a maximum distance and then travel back down. But the time it takes to go up will be the same it takes to travel back down, and so the value for t that we will get from our equation of motion will need to be doubled to find the total time it takes to return back to the starting point. And so the equation we will use is V final equals V naught plus acceleration times time, and we can manipulate this to get time equals V final minus V naught over acceleration. And this will actually give us t1 half, and that will be 1.07 times 10 to the negative 8th or seconds, and if we multiply this by 2, this will give us the total time of 2.14 times 10 to the negative 8 seconds. And to make this answer a little prettier, we can multiply 2.14 times 10 to the negative 8 seconds by 10 to the 9th and get 21.4 nanoseconds, which is the total time it takes for the electron to return to its starting point.